Good morning, everyone. Now, question number 66. Without performing actual long division, how can you tell if a rational number p by q will have a terminating decimal expansion? Without performing actual long division, right? Now, answer is a rational number p by q in its lowest terms. That means that is in the form of simplified form or simplest form. That means the both numerator and denominator having no common factors other than 1 will have a terminating decimal expansion if and only if the prime factorization of denominator q contains only the prime factors of 2, only the prime factors of 5, or only the prime factors of both 2 and 5. That means the denominator can be expressed as a prime factors of 2 to the power of m into 5 to the power of n. 2 to the power of m into 5 to the power of n, where m comma n are the non-negative integers. Okay. If the given fraction is in the form of simplified form and the prime factorization of the denominator can be expressed in the form of 2 to the power of m into 5 to the power of n, that means denominator having prime factors of 1, only prime factors of 2, or only prime factors of 5, or only prime factors of 2 and 5. That is in the form of 2 to the power of m into 5 to the power of n, where m comma n are the positive integers or non-negative integers. In this case, the given fraction is a terminating decimal. Now we have here two conditions. First one is the given fraction must be a simplified form. Must is in the form of simplified form. So simplest form. Second one, the prime factorization of the denominator can be expressed in the form of 2 to the power of m into 5 to the power of n, where m comma n are the non-negative integers. When the given fraction can satisfy these two conditions, then that fraction is a terminating decimal. For example, 1 by 20. Here numerator 1, denominator 20 are having no common factors other than 1. Therefore, this is in the form of simplified form. Now denominator 20 can be written as 2 square into 5. This is in the form of 2 to the power of m into 5 to the power of n, where m is equal to n, m is equal to 2, n is equal to 1. These two are the non-negative integers. Therefore, 1 by 20 can satisfy two conditions. That is the simplest form, and denominator can be expressed in the form of 2 to the power of m into 5 to the power of n. Therefore, 1 by 20 is a terminating decimal. Now, next question, 67. The base of our question, why do prime factors other than 2 or 5 in the simplified denominator cause a non-terminating repeating decimal? Non-terminating repeating decimal. Now answer is, the base of our decimal system is 10. Basically, our decimal system based on 10 are exponents of 10. whose prime factors are 2 and 5. Any fraction whose denominator cannot be multiplied to become a power of 10 because it contains prime factors like 3, 7, 10, etc. cannot be expressed in a finite decimal and must repeat. Okay, now here we have two conditions. When the given fraction is a simplified form and the denominator can be expressed in the form of 2 to the power of m into 5 to the power of n, the denominator can be expressed as a powers of 10. For example, 3 by 20. This is in the form of simplified form because both 3, 20 are having no common factors other than 1. Here 20 can be expressed 2 to the power of 2 into 5 power 1. This is in the form of 2 to the power of m into 5 to the power of n. Now we can multiply with 5 to the both numerator and denominator. That gives 3 into 5 by 2 square into 5 power 5 into 5. That is equal to 3 5s are 15 by 2 square into 5 square. That is equal to 15 by 10 power 2. When the given fraction is in the form of simplified form and the denominator can be expressed in the form of 2 to the power of m into 5 to the power of n, then that denominator can be expressed as a powers of 10. Powers of 10. In this case, this type of fractions are known as terminating decimals. Now one more we have, that is when the denominator is in the form of when the fraction is in the form of simplified form and denominator cannot be expressed in the form of 2 to the power of m into 5 to the power of n. That means the prime factors of the denominator are other than 2 and 5. In this case, the denominator cannot be expressed as a powers of 10. Now one example. Suppose 7 by 15. Here both numerator and denominator are having no common factor, therefore this is in the form of simplified form. Now here denominator 15 can be expressed 15 is equals to 3 into 5. Here 3 is presented, that is other than 2 and 5. Okay, other than 2 and 5. When the prime factors of the denominator having other than 2 and 5, that fraction is a non-terminating repeating decimal. That denominator cannot be expressed as a powers of 10. Therefore, here 15 cannot be expressed as a powers of 10. Therefore, 7 by 15 is a non-terminating repeating decimal. Non-terminating repeating decimal. Okay. Now, question number 68. What is meant by the period of a recurring decimal? Period means the digits which are present in the recurring part or recurring block. The digits which are present in the recurring block is called period. The period is specific sequence of recurring digits that repeats infinitely in the decimal expansion. Period means the digits which are present in the recurring block or recurring part is known as period. Suppose for example 2.234 34 34 and so on. This is a non-terminating recurring decimal. Here 34 34 34 is repeating here. So repeating black 34. The digits in the repeating black means 34. Therefore here 34 is known as the period of the 2.34 bar. Okay. The digits which are present in the recurring part. One more example. 1.071 071 071 and so on. This is a non-terminating recurring decimal. So your repeating block is 0.017. Repeating block is 071. Here 071 is known as the period of the 1.071 071 071 and so on, or 1.071 bar. The period of the 1.071 bar is equals to, what is the answer here? 071 or 71. So that is repeating black. The digits in the repeating black is known as period. Next, 3.456 456 and so on. So this is a non-terminating recurrent decimal. This can be written as 3.456 bar. Okay. The digits in the recurring part, that means 456 is a period of the fraction 3.456 456 456 non-terminating recurrent decimal. Right. Now next question 69. What is meant by the periodicity of a recurring decimal? Periodicity means the number of digits in the recurring part లో ఉన్న digits యొక్క సంఖ్య. The number of digits in the recurring part is called periodicity. Periodicity is the count of digits present in the repeating block. ఆ రిపీటింగ్ బ్లాక్లో ఉన్న డిజిట్స్ యొక్క సంఖ్య. ఫర్ ఎగ్జాంపుల్ 0.33333 and so on. This can be written as 0.3 bar. Here repeating block is 3. Okay, periodicity is number of digits in the repeating block. How many? 1. So periodicity is 1. Period is 3. Now one more example. 2.34 bar. Period is equals to 34. The digits which are present in the repeating block 34, that is known as period. Periodicity, number of digits in the repeating block. Number of digits. How many digits repeated here? Only 2. That 2 is known as the periodicity of the non-terminating recurring decimal of 2.34 bar. So here periodicity 2, period is 34. Right. Now next question. 70. When converting a non-terminating repeating decimal like 0 bar 6, 0.6 into a fraction p by q, we do multiply the equation by 10. Right. Here we know the main reason, especially for cancelling infinite decimal part, to multiply 10 or exponents of 10. When the given fraction is a non-terminating repeating decimal, we can multiply 10 or exponents of 10. What is the reason here? For cancelling infinite decimal part. For cancelling infinite decimal part. Decimal part ni cancel cheyadaniki 10 or 10 powers తో multiply చేస్తాం. What is the main reason here? Especially for cancelling the infinite decimal part. For example, 0.6 bar, this is equal to 0.66666 and so on. Now what is the periodicity here? 1. When the periodicity of a given non-terminating recurrent decimal is 1, now we can multiply with 10 on both sides. Or suppose the periodicity of a given fraction is 2, we can multiply with 10 power 2. The periodicity of a given fraction is 3, we can multiply with 10 power 3. Why we can multiply 10 powers? What is the main reason here? The main reason is specially for cancelling the infinite decimal part. ఆ ఇన్ఫైనైట్ డెసిమల్ పార్ట్ని క్యాన్సిల్ చేయడానికి 10 or 10 పవర్స్తో మల్టిప్లై చేస్తాం. సో దట్ ఈస్ ద మెయిన్ రీజన్ హియర్. ఓకే.